Today I'll be checking to see if an MTP version of a large language model can make the use of local AI just that bit more bearable on consumer hardware. MTP stands for multi-token prediction, which I'll explain shortly, and it's somewhat of a new thing in the world of LLMs. Take Qwen 3.6 27B for example. It's already a fantastic local model, but any improvement in speed, even on my M5 Pro Macbook, would certainly be a welcome addition. I'll be using LM Studio for today's tests, which recently updated its engine to support these new MTP models. I'm downloading the Unsloth MTP version of Qwen 3.6 27B at Q8 quantization, which matches the non-MTP version model I already have, so we can compare the two. So what is MTP, and why is it supposed to make LLMs faster? To understand it, we have to look at the old way we tried to speed up AI models, which is a technique called speculative decoding. Normally, an AI model writes text one single word or a token at a time. It's highly accurate, but it can be slow. With speculative decoding, you load up your massive, really smart model, but you also load up a second, tiny, less smart draft model alongside it. The tiny model sprints ahead, instantly guessing the next 3 or 4 words. The big model then reads those guesses and says, "Yes, that's correct," or "No, let me rewrite that." It speeds things up because checking work is faster than writing it from scratch. But the problem is, running 2 completely separate models at the same time eats up a ton of your computer's memory. With MTP, there is no second tiny model. Instead, the main, in our case Qwen model, has been specially trained with draft heads built directly into it. It essentially thinks ahead on its own. It guesses the next 2 to 4 words in a single pass, and then the main brain of the model immediately verifies them. If the guess is wrong, it throws it out and writes the correct word itself. But if the guess is right, it accepts them all at once. Because the main model always has the final say, your output quality stays frontier level. It's essentially the same logic, just delivered faster. So first, let's take a look at the non-MTP version and give it a simple speed test in LM Studio. So the first model we'll be loading up will be the Qwen 3.6 27B Q8 non-MTP version, and we'll give it a context size of 32K. We'll give the model the prompt, write 2 paragraphs explaining why cats always land on their feet. With a time of 0.59 seconds to the first token and a thinking process which lasted 2 minutes and 8 seconds, it produced 1,482 tokens and gave us a token speed of 9.49 tokens per second. Next, we'll load up the MTP version and give it the same prompt. I shall copy that for ease. And we'll give the MTP version the same context window, and we'll paste in the same prompt. And with a time of 0.67 seconds to the first token and a thought process of 43.19 seconds, it produced 1,057 tokens and gave us a speed of 16.51 tokens per second. 16.51 tokens per second is 1.74 times faster than the non-MTP version. The next test that I want to give the 2 models is just to build a simple HTML expense tracker, not to compare the actual performance speeds of the models, but just to compare side by side the expense trackers to see if there's any difference in the capability of the coding. Hopefully they'll both work and we'll have something to compare at the end. So both the non-MTP version and the MTP version of Qwen 3.6 have finished coding the expense trackers. On the left is the non-MTP version and on the right is the MTP version. And I think you'll agree that they're very similar, but I'd say that the MTP version was just a little bit better laid out. They both work the same. I've added a couple of expenses to the lists. It looks like the MTP version puts them in order that they were put in, and it looks like the non-MTP version just puts them in reverse order, with the most recent being at the top. So I guess if you ran this a few times, you might get the MTP version doing a mistake like this, but the fact that the MTP version has done it straight away and looks better than this one just shows you that the quality is still there in the MTP version, despite it being almost twice as fast as the non-MTP version. So to sum up, I think MTP can only be a good thing. You can run the same model on the same hardware but get nearly twice the speed. So if you've liked this video, please consider painting the thumbs up button, and hopefully I'll see you in the next one.